Okay, good morning and very warm welcome to our CIVIT Technology Day. This is the next in the series of such events we try to organize at CIVIT. And for each Technology Day we try to have a focus. And the focus of today's event is about virtual reality and VR walkthrough. So we wanted to, the previous one was about the art and tech of 360 video. Now we go more toward the visual experience. And we like to use this snow picture as a metaphor of the individual experience of everyone going through the use of new immersive technologies. So welcome once again. Thank you for coming in this cold day. I hope it will be worth attending the event. This is the program. We are waiting for the dean to come and welcome you. He has to open another event, so we are quite dynamic university with a few parallel high quality events running. So he should be here anytime soon. Then we have several interesting presentations which are going to be presented here. The first one is by Markos Magnor for Technical University of Braunschweig, Germany. He came all the way from Germany to share his experience and vision about these technologies. Then I'll present briefly the state of CIVIT, which we call CIVIT 2.0, because of the new installations, because of the new premises. And actually one occasion of this event is to to celebrate the new premises which we moved to this summer. Of course, setting a center like an infrastructure unit is a long-term task. So it is not complete yet, but it is in the form to be operational, and you are all welcome to check the premises, the equipment, and the services we are offering. Next presentation is going to be by Urho Konturi, the CEO of Varjo. This is a startup company from Finland, developing an advanced headset, VR headset, where we call their presentation resolution revolution because they are able to maintain the resolution depending on where the person is looking. More from Urho. However, maybe because of the weather, because they are coming from Helsinki, they are not here yet. So we hope they will find their way. Anyway, we can at least reshuffle the presentations and continue before lunch with the presentation by Richard Guilfoyle from Omnifinity, Sweden. This is the company which delivered the so exciting Omnidirectional Treadmill, which we will have also the opportunity to try and experience in the demo session. We have Luke Noonan from Rust. This is a development company dealing with all possible VR experiences, and he's going to share his lessons from the trenches. The speakers are invited to a panel after all, so we can have a more informal discussion. So I'm going to ask few maybe easy, maybe provoking questions, like to get a common understanding and to share opinion about the trends and the current state of these technologies. We are running a set of demos which will start after the panel. The Omnidirectional Treadmill by Omnifinity will be demonstrated. Hopefully the Varjo guys will come and show their so-called bionic display. The CIVIT equipment, like the current LiDAR we got, will be demonstrated, and in terms of data, in terms of application of this data. We have a quite interesting mobile robot with a mounted gimbal on top of it. The white light field display will be also demonstrated, this time with our own results of processing of reconstruction of light fields. Also, we have another prototype developed at the center, what we call transparent 3D head-up display, which will be also on display during the demo session. For the omnidirectional treadmill and for the Varjo headset, we ask people to book times, because this is like individual experience. The times are working as scheduled for the omnidirectional treadmill. So if you have booked your personal time for trying, for testing the device, you can follow it as originally scheduled. Unfortunately, the Varjo guys are not here yet, so we cannot demonstrate their display. They have to bring their own prototype, which also we haven't seen. So the demo of their display will be somehow rescheduled. So anyway, we'll try to serve you best in all aspects of the day. We had to use this room, which is quite small, because of its proximity to the lab, so we didn't want to ask you to walk through all university buildings. So there was quite high interest to the event. There are still places inside, so if there are people outside, they are welcome to join the presentations. The event is also streamed over YouTube. So if you go actually to the web page, which is TUTFI CIVIT /index PHP and then VR throughout, you will find you will find the link to the YouTube stream. So you can also share this information with your colleagues who are not able to come physically for the event. Yeah, this was what I had to share. So Mika promised to be here, so let's here. Okay, okay, you have the floor.
Yeah,
Sorry
thanks.
I was looking at the door.
Yeah, I noticed that you were kind of not seeing me very much here in the front. So welcome all. My name is Mika Grunström. I'm the Dean for the Faculty of Computing and Electrical Engineering. And Atanas forbid me to use any slides. And usually my speeches are long and tormenting. So I tried to make a short one this time, and let's see how I'll manage to do this address this morning. So it's a pleasure to welcome to you to this Technology Day of CIVIT. This is also stands for the grand reopening of the CIVIT, as we have now shaped the new premises for the infrastructure, which are next to us, and you heard already a lot what is happening there by the presentation of Atanas. And I think it's important as for the research community, it comes as what we can offer in a very tangible terms to the research community and partners alike. So CIVIT is a milestone. It is a great achievement of a long-standing research work of Tampere University of Technology. It has its roots in signal processing and its applications in image, video, and multimedia, which is now turning into the long research topic of 3D in different forms, including the augmented and virtual reality. And that stretches to the human factors and even to gamification in the current research agenda that we have for the faculty. The strong and internationally recognized research has impacted the developments of the new technologies and moreover created a vivid and professional network of experts contributing to the society and economic growth of the region at large. So why is this important now? Why is it now that we actually talk very much about the research infrastructure? So the research infrastructure is the framework that allows you to do certain things. And for us, of course, it is a tool, and that should be the tool that attracts the research and the researchers alike. So what we like to do is we like to do this together with the partners and cooperators, academia, universities, internationally across the world. Alike, we like to do this with the industry members and welcoming those to use and join the developments to create something new. So there are many actors in play, and all of those actors, I think, can contribute and help creating the new things that are becoming then visible in few years out of this research. The research infrastructure investment has been done together with the help of the Academy of Finland, initially contributing €1 million to developments, and then the Tampere University of Technology putting another 1 million, resulting in €2 million investment in total. And as the technology development is so fast, of course, we need to take care as the faculty level that our investment and this infrastructure keeps up to the shape. So we have continued to invest in the reshaping and redoing equipment for now and few years to come. So we try to really keep it fresh and usable to the research and the research communities. So, and it's also notable that this is also the Academy of Finland Finnish research infrastructure part. So this is really a part that is open to the academia and different universities alike. So I thank Atanas, Robert, Olli, probably they are on the other room doing the demos, and the team putting this together. I think it has been great effort, and I'll expect to see good things come out of that. And of course, I'd like to thank Academy of Finland and Tampere University of Technology investing in this. For our faculty is one of the core areas that we have identified in the strategic profiling that we did last year. And now we are kind of through this kind of infrastructure putting that into the real implementation. So I wish you all informative, thought-provoking, impactful day. Thank you.
Thank you very much, Mika, for the nice and encouraging words. So we are quite enthusiastic to continue with in the same way. And speaking about continuation, we are going straight to the first presentation, which is entitled Immersive Digital Reality by Professor Markos Magnor, the head of the Computer Graphics Lab of the Computer Science Department at TU Braunschweig, Germany. He has BA and MS degrees in physics from Würzburg University and the University of New Mexico, and a PhD in electrical engineering from Erlangen, and he has held a postdoc position at the Computer Graphics Lab at Stanford. And actually, I've known Markos from one big European project called 3D TV, when 3D TV was a big thing. Now we have VR, which is pretty much the same about delivering the 3D visual experience to humans. And he is also having one of these highly prestigious ERC grants. And with research interests in visual computing, visual information processing, image formation, acquisition analysis, and image synthesis, display, perception, and cognition. So I think that he is the best person to give the first talk in today's event. Please, you're welcome.
Atanas, thank you very much for your very nice and warm words. I'm honored to be here today. Atanas invited me, I think it was shortly before Christmas, and it took me just a moment to decide that I cannot miss out on the opportunity to come here today. And you know, these are very important days for our field. Those of you who registered in time, you were able to come to Tampere. Everyone else who didn't make it in time had to travel all the way to Las Vegas to some consumer electronics show there, and I read about it on the airplane yesterday. So I think Google announced a standalone VR headset, and Facebook, Oculus did the same, which are good news because these big companies are still believing in the technology and in the applications and in the business model. So the not so good news that I read in the paper was that in the US they expect revenue in this area to be about $1.2 billion this year, which sounds like a lot of money, but for the analysts that was kind of disappointing. They had expected to make more money in VR. And if we remember back the hype like 3 or 4 years ago in this field when Oculus started with the Rift, it felt like this was going to be the next big thing, and we're all still waiting for it to be the next big thing, I pretend to say. So let me start looking at where we are and where we want to go and what needs to be done from a research point of view. I'm from a university, so we don't have much money to build fancy hardware. We have to live with what we can build ourselves or what we can buy for little money. But on the other side, we can concentrate on the research part and don't have to produce working prototypes that we have to sell. So that's the good thing. Let me start looking at this thing from where television sets are right now. I'm sure you know that we are now with Ultra HD resolution at 4K. You can buy television sets at that resolution now. They are 1.50 meters, 2 meters diagonal. So if you have a standard living room, that is already almost immersive because it's going to fill up your entire window. You have OLED technology, you have LCD, LED technology being perfected. So you have very brilliant colors, you have great contrast, you have high dynamic range technology, so you can display dynamic range 10,000 to 1. All these things seem to be almost solved, I would say. So the images that you can watch on a big television set are almost as if you were really there. The thing that this community did about 10, 12 years ago was they introduced stereo, mainly, of course, from the movie industry and the movie theaters, which was their way of forcing the movie theaters to go digital. So Hollywood would know which movies were shown how many times because they would be able to track that instead of just giving out the copies and not really knowing how often it was run. But anyways, so what we gained from that was stereo. We all wore these funny glasses and enjoyed seeing the world in 3D. Again, it had been around about 40, 50 years ago already. Of course, now it's all perfected and technologically much better, but essentially it was the same thing. And the movie directors first loved it, and then they hated it, and now there are some movies coming out in 3D, and most are coming out in 2D again, and some are coming out in both, and so not really clear where that is going. It used to be a big thing as well at that time. Okay, and then from that point on, we got immersion. We got our head-mounted displays, which you could build yourself using this cardboard that Google put on the web and just use your smartphone, or you could spend a little bit of money and get something better. And this was a huge thing and success in a way that suddenly the general audience would know about VR and head-mounted displays. Now, for people who have been in that business for 20 years, that was nothing new. VR headsets have been around since the 1980s, I believe, but they were expensive. They were only confined to the lab. Now you could actually use this at home. If you look at just the characteristics that I put up there, I didn't put a mark for frame rate, latency, and so on for these headsets yet, because, as you know, there are still some issues with that. It's not as perfect as if you had a big TV set at home, and that would be the standard. That's where you want to go. So the question is, what do you need to do to get there? And I will address that and give you a couple of ideas that might resonate with you, and you might get something out of it. There's one more thing I have to add to this, which is motion parallax. If you're able to track the head position, you're able to have ego motion parallax, that is, move around the object. And that's actually very important, I think. If you look at what's out there in the marketplace, and if you look at the VR goggles that don't have motion tracking, it's getting strenuous in like 10 minutes or so. You really want to be able to see what is happening to the scene when you move your head around. That is what makes it interesting. So that is something that I think needs to be added, not only from the motion tracking side, but also from the image creation side, which is very simple for 3D scenes. If you have computer graphics there, you can create any viewpoint in a snap. But if you wanted to do that with a real scene that you have recorded with a video camera, it's not that easy. So that is something that I think also needs to be worked on. Now, in the next 40 minutes or so, I would like to present to you 3 different gadgets that you could add on, or ideas that you could add to standard head-mounted displays, and see how you could improve on these points that are still have these wavy lines there, and at the same time maybe get something more out of it. And the first idea that I would like to present is something that I'm sure will be presented in more detail and in a more perfect manner by the next speaker, by the company Varjo. We had essentially, obviously, the same idea a couple of years ago, just to add eye tracking to your head-mounted display. And if you know where the user is looking, you can use that information to improve on latency of the rendering. You can improve on the perceptual issues, and you can also add depth of focus, as well as eye contact if you have several users in your VR space. The prototype that we built looks like this. We just used a 3D printer and a standard dichroic mirrors that are transparent in the visible and reflective in the infrared, which is a standard technique. Use some infrared LEDs here and some infrared cameras to record the pupils. And that way we were able to record where the person was looking, having calibrated everything. The entire set, of course, consists of some more parts. So the PhD student had some time to work on this, to create a working prototype, get his lenses right and the calibration, all these things. But in the end, what we got was something like this. You see one of the eyes being tracked here on the right-hand side, and then the prototype with the glowing, actually this is infrared light, the glowing illumination for the eyes. And with that, we got a system that worked with a very low latency on the PC, about 12.5 milliseconds. If you used the Raspberry Pi, it was about 3 times that time, but you can always improve on the timing. And the resolution, the angular resolution accuracy was about 1 to 2, maybe 3 degrees, which is not perfect, but which is sufficient for a couple of things that we wanted to do. And the first thing that you can do now, which is very simple, is you can now use the information where your user is looking to mimic depth of focus. You just render the scene in focus where the person is looking, and the rest of the scene, the front and the back, you just use some clever algorithm and render that unsharp, which gives you a more naturalistic feeling of what is really out there, because now you have at least the impression on the retina that the scene is out of focus where you're not focusing. It's not exactly the same thing as in nature, because when you look at something, your lens is adjusting its focal length, which is not the case with a head-mounted display. But for the brain, this I claim looks already pretty convincing. Okay, the next easy thing to do is then just to use that information and render your avatar with the eyes blinking and looking at a certain point. I know that Facebook is, I'm sorry for the avatar. It's kind of strange. Just look at the eyes, okay? I know that Facebook is researching this topic at their lab in Zurich. Their idea is to use head-mounted displays for social VR. So instead of Skyping with someone, you would just use your head-mounted display, and you would see the other person's avatar and just talk to him as if he were or she were there. But if you can't look someone in the eye, that's very annoying. And if you can't read the facial expression, that's also very annoying. So the next thing that would have to be added now is to kind of get the mimics of the face, even though you're wearing these goggles. And I'm sure they're working on this as well. There are papers on it already. But looking at someone is one of the key things that you want to include if you have several people working collaboratively in VR. Okay, the next thing takes a bit of preparation here, which is that the resolution of the HMD is more or less uniform over your angular space. I mean, yes, you have distortion because of the lenses and everything, but because you have a regular grid of pixels there, let's say it's just a uniform display resolution. And we all know that your fovea resolution is still much better than what the display can provide. Yes, say you have a 2,000 pixel display, you cut that in half for each eye, and you now spread those 1,000 pixels over, say, 100 or 120 degrees, then you have something like, say, 8 or 10 pixels per degree, and that's not enough really for the acuity here. But that's only where you're looking. That's where you're focusing, where you look when you're concentrating on something. Your entire peripheral vision has much lower resolution, or not much lower, but considerably lower. And so there's resolution wasted, obviously, and actually it's quite a bit. It's about 90, 98, 95% of resolution that's not being perceived at the rendered resolution because it's in the fovea, in the periphery, I'm sorry. So even though you cannot do anything about the display, you might be able to exploit this fact to increase rendering times, to just render quicker, because you could get away with lower resolution out here. So for that to work, you have to know where you're looking. Well, that is something the eye tracking gives you. But then in the periphery, it's not that simple. You cannot just blur everything to the side or anything, because if there's something blinking or if there's something bright, you will still perceive it, and you will also perceive that it's something important. You might be saccading to that point next moment. So you want to be adjusting your resolution, your rendering resolution, to what's in that scene. And it's even more complex than that, because there's not just one thing that's blinking or a bright highlight, but there are many different things. So you might end up with something that looks like this. The first thing of all is, of course, you have to come up with some idea of what is the correct resolution that you want to use for different regions of the scene to render. And my PhD student came up with this, and I'm not going to explain this to you. If you're interested in it, please read his paper. He's been looking at lots of psychological papers and went through the studies that they did on what we perceive and what is not being perceived and masked, and then came up with this algorithmic model where he's taking into account the material, specularity, edges, movement, all these things. And then he developed a rendering algorithm that is making use of this information using something that is called deferred shading. And instead of just rendering this scene one triangle after the other, it's actually more like a stochastic process. He's rendering some regions, he's sampling at a higher resolution than others, and the rest is then just being filled up. For that to make sense, this GPU rendering time, so this is the rendering time or the display time for a single frame. You want to concentrate on the GPU time, which consists of 3 different parts. The shading is the part that is the most expensive one if you're rendering with complex algorithms that are supposed to make the scene look realistic. So you want to save time here by doing this foveal peripheral rendering. And so this is then being actually, yes, reduced. And you do need to do some gaze contingent sampling beforehand and the image interpolation of the holes after that. But in total, this time here is less than that. So you end up with a better frame rate, higher frame rate. And just to show you what this looks like, here's a scene that he rendered. If you're looking at this red cross here, so this would be the ground truth rendered in full resolution. And if you had just noticed, this was now switching over to the per pixel shaded reference, to the adaptive reference. And if you're now at the right distance, and if you were looking at this, for example, in a head-mounted display, you could actually see no difference, almost no difference. At the moment where it's changing, yes, you do see that there's something changing, but you could not say that one has a higher quality than the other. And that's the important thing. And you're rendering at a higher frame rate. And what you see here is the output of the psychological model. What is important, what should be sampled at a higher rate, and what, where can you get away with less samples. Okay, let me go on and talk about another approach that you could do, which is use gaze guidance, or know in advance where the user will be looking. If you do eye tracking, you know in real time where the user is looking, and then you can try to react to that, but you only have something like, say, 30 milliseconds to do that, which doesn't give you all the opportunity that you might like to have. If you had more time, could do more algorithmic magic, would be better. So instead of doing eye tracking, you could say, let's create a scene where we already know where the user will be looking. And if you don't do anything about it, these are just eye tracking examples for one panorama scene here for, I think, 5 different users. And you see that sometimes they look to the same spot, but then they diverge and look into other directions. So you could not really create one version of this video offline that would suit everyone. Or the other way around, they would probably notice that something is not right because they're not looking at the right spot at the right time. So ideally, you would like to have everybody looking at the same point in the scene at the same time. Now, if you're a movie director, essentially you've solved that problem, or you've learned how to do that, because when we watch a movie made in Hollywood right now, we all more or less look at the same scene areas at the same time because we're being directed to that direction. Now, it's not as clear how to do that in 360, but there is a technique out there called subtle gaze direction. It was presented 8 or 9 years ago at SIGGRAPH, where people showed that if you were showing this kind of stimulus here in the periphery, you would saccade to it with pretty consistent results. And if you turn this off at the time where you've saccaded, let's say you have an eye tracking device again, you would not be consciously aware of it. So you would saccade to that point, but you wouldn't know why, because you wouldn't see this anymore. And this is kind of the trick behind it. And what they proposed was to use a Gaussian blob that was flickering at about 10 hertz. Now, how do you, and that was at that time done on a display, just an ordinary monitor. If you were to do that in a head-mounted display, the question is, of course, what size does this blob have to be? And you could also play with the other parameters. We just looked at the size and just did a user study where we placed this blinking at 5-degree intervals, and then and then asked people to look at the small circle here in the middle and just give notice when they recognized it. And what comes out is about this curve here. So the farther away you are from the foveal region, the bigger this blob should be for it to be recognized. Well, okay, that's good to know, and especially what is good to know is the slope of this line. because you don't want to have it too big and not too small either. Second thing is, if you have now a more complicated scene and you were now doing the same thing, how does that affect the results? How much bigger would this blob have to be? Because now the scene is more complicated. You have this masking effect maybe, and turns out, well, you also have more or less a linear dependency here, and if you show both in the same diagram, you see it's a little bit higher, but you could still see some relation there. So you could use now this information if you were to create a gaze directing algorithm for head-mounted displays. Last thing we did was then see how that helps if you are given the task of finding a certain object in a cluttered scene. And say you were given this image and you were told, not an image, it's like a panorama. You're in 360. And you were asked to find the sphere, which is, for example, hidden almost. And people are looking around trying to find it. And then the second run, you show this subtle blinking in that direction and see how much longer or how much time do people need now to find this place. And we find here the blue trials are the ones without the flickering, and the orange ones are including this gaze directing technique. And we see that the numbers go down, the time to find the object goes down, especially if you have complicated or difficult examples, as for example the sphere that is almost occluded by some other object. So what you see here is the saccade, or the search movement of the eye over time to find the object, the angular distance. And you see that it's going down, and it's much quicker here, especially for difficult cases. So you can use it for that as well. Which might be also helpful if you were to direct the user to look at something that is not out of his field of view. Let's say the action is behind him, but he doesn't know it because he's looking there. How is he supposed to know? Well, of course, you can do this with acoustics maybe, and alternatively, maybe you can use some gaze directing technique to kind of let him walk his gaze over to the other side. So let's say you know where your user is looking. That helps you to prepare this scene and prepare the footage that you're presenting. And one thing that is important is if you have a fast-moving scene, something that is moving quickly and that is being rendered or displayed at a finite frame rate, of course, that you can get aliasing, and that this aliasing gets kind of annoying. Say, for example, you have this biker here, and he's flying through the air pretty quickly. The camera is following, so that everyone is, of course, focusing here on the bike. But the camera is not moving exactly on spot. So you have to have a very short exposure time, which gives you very sharp images in the back and the front, perfect. But if now the frame rate is, say, only 60 hertz, the background will be jumping many pixels from one frame to the next, and you will see that in a moment. If you use a longer exposure time, things will get blurry. Ideally, you would like to have the foreground object in focus and sharp, and the background blurred according to the motion blur that's stemming from the finite exposure time and the finite frame rate. Just to walk you through this, say you have something that is moving in the scene from here to there, which in this case here would be the background. And you have something else that is moving upward, and your eye is following this object that is moving upward. This is known as smooth pursuit eye movement. Typically, we can only jump from one point to the other. Yeah? If you try to move your eye continually along a row, that doesn't really work. You always jump. That's what the psychologists tell me. The only way of having a smooth motion of the eye is if you're following something that's moving through your field of view. And so this is called smooth pursuit eye movement, and that is what's happening right here. And so in nature, what would be visible on your retina for the background that you're not tracking, say something like this. So this is this linear motion and that linear motion superimposed. Okay? This would be the real thing. This is ground truth. If you're recording the scene now with the camera, say with the 2 frames, what would happen is you have an exposure time, and the background, and the camera is moving now, not the eye, now the camera is moving that way. You would have blur, motion blur, and then you would have motion blur there, but you would have this jump. And this doesn't look natural. And if you were to, if you now include the fact that a camera also has a dead time, just to read out the frame, you would get this hole in the exposure time. So now in addition, you even also get ghosting artifacts in there. You could now go ahead and increase the frame rate of your camera. Say you just spend more money on a high-speed camera and have 4 frames. It will alleviate the problem, but it will not solve it. You will still have these blocks here instead of having a straight line. And the idea now is to create something that on your retina looks like this by doing something with the images beforehand, before you show them on the display. And these are already the results. This is a static camera looking straight ahead. And there's a bicyclist riding by pretty quickly. If you have very short exposure times, then a single frame of the camera looks like this. Camera is, the bicycle is sharp, the background of course is sharp, and that's fine. But if you now have 1 frame and the next, this bicycle will be jumping from one to the next, ghosting, because the frame rate of the camera is not as high as what you would like to have to see it in smooth motion. Same for the display. If you now have long exposure, what would happen is that the bike will get blurred, of course, because that's the moving part. The camera is static, the background remains static. However, because you're following the interesting thing in the scene, you're following the bike, you see it blurred. You want to see the bicycle in sharp focus, but instead you want to see the background blurred appropriately. So this is what you want to do. And if you don't like bicyclists, you can also take skateboarders. Okay. Other thing is if the camera is moving around the object. So if you have short exposure, look at the background. You might see that it's kind of a ghosting artifact there. And then if you have a long exposure, you see, if you look closely on the object, that it's more blurred. With a perceptual filter, you can keep the foreground in focus and sharp, and the background is blurred accordingly. And here we have the motocross biker again, which is the original sequence. Look at the background, how that seems to be jumping. If you have a long exposure, the bike is not sharp. And if you now do the right filtering, it looks better. Okay, so that is another thing that you can do beforehand, but it takes longer time. So you cannot do this right away with the eye tracking, because you have to analyze the scene somewhat. And it's all automatic, but it takes more than 30 milliseconds to do this. Another thing that you can do when you know where this smooth pursuit eye movement is happening is you can artificially, or perceptually I should say, perceptually increase the resolution of your screen at the expense of what you need for that is a high frame rate. Let's say that you have a display that has a pixel size that is still considerably larger than the angular extent of one receptor in your fovea, which for the time being is still a valid assumption. Otherwise, it doesn't make sense. If your resolution is already at foveal limits, we don't need this anymore, but let's say we're not there yet. At least with HMDs, we're not. And let's say you have a high frame rate, 120 hertz or better. With HMD, we're not at 120 hertz yet, but I would assume that we are getting there if there's use for it, and I say there is. So this 120 hertz is much higher than our flicker frequency, at least in the foveal region. And now the idea is, or now what we need is the smooth pursuit eye movement. I just explained that. Your eye is following some foreground smoothly. So the foreground object is fixated on the fovea. Our ocular system is very efficient at that. And so if you now look at a single receptor in your fovea, the color and brightness that it perceives is determined by a certain integration time Even our eyes are not perfect singular entities, but they also need to integrate over time to get a signal. And depending on light level, this integration time can be up to 100 milliseconds. So this is the minimum flicker frequency of 10 hertz. Maybe a little bit less, but let's just say 100 milliseconds here. And now there is this paper by Didic et al. 8 years ago, very good paper. And they had the idea, ingenious idea, of exploiting this smooth pursuit eye movement and the high display frame rate to show a sequence of frames on the screen such that for the moving eye, a single receptor over its integration time can get a better, or can get distinct information on the scene that is then essentially giving a better resolution. And because I cannot explain this just in words, let me show you a small video here. So this is the work by Didic. They have something that is moving, and that is important, diagonally. And if it's moving diagonally and our eyes are following it, smooth pursuit eye movement, some point within this hay bale here, then for two different receptors in our fovea, the green and the blue one, over the integration time, they will see these integrated colors here, depending on what they covered there. And by just now steering these pixel colors quickly, they can now per cone more or less get a better resolution. The thing is, the scene has to move diagonally, and the entire scene. So here for the background, you would not get any effect. And if something was moving just in vertical direction, you would not have a resolution enhancement in horizontal direction. And now there you could do something with if it's moving diagonally back and forth, but if you have motion like this, it's getting difficult again because you don't know where people are looking. Okay, so the underlying idea is great, just that it cannot be directly applied to arbitrary video. Now you need this diagonal direction so that you can address every cone individually. Otherwise, you only have the horizontal or the vertical direction. And so the idea is now, of course, just add motion in the right direction so that it's not, so that it's enabling this effect of apparent resolution enhancement, but without interfering with the story or the scene. So ideally, you don't even see that something is moving. And for that, that's essentially an optimization problem for a given scene. So here, nothing is moving. And if you were now just moving it back and forth within that frame, well, you clearly see that there are these kinks where the motion stops and goes in the other direction. And so you're defining an optimization function there, and then also taking saliency into account, you come up with an optimal motion path that you can then still edit so that you get best possible results. I cannot show you the true results because I can't show you 120 hertz frames on my laptop and this projector here. But there's code that you can download, and if you have a 120 hertz display, you can try this out. Just to show you that the motion is really almost imperceptible, you don't see much difference between these two, I believe. And for these two sequences, the same thing, or here. Now, the important thing is you don't see the difference between the motion that the director added and the motion that is now being added by the algorithm. Okay, let me come to the third big thing, and I mentioned this already in the beginning, which is how to import the real world into head-mounted displays. So far, most of this was, if you wanted to react to something, was computer-generated. But I think the big thing in visual entertainment is if you can watch a real-world scene, either on your TV or, next step, immersively with your VR goggles. For that, you need to record the scene, of course, and not just model it with Maya or Studio Max or something like that. And I'm sure some of you at least have tinkered with this, and if you use these toys that you can buy for, I don't know, $100 as cameras, you get lousy resolution. If you really want to enjoy a recorded scene, you need professional grade resolution, and we can talk about what that means. And you need a high frame rate, and the dynamic range must be decent. You see, how this is much brighter there than here, and the shadows, and so on. And if you want to do that, you're facing all these challenges. You need probably more than one camera or one CMOS or CCD chip, and they should be synchronized if you have more than them. And if you use more than one, they will have different color responses, so you need to grade them, and you need to stitch them together to get a panorama. Then these cameras will not have the same center of projection. So you cannot just take these images as are and then just combine them. You need to warp them accordingly. You would have motion blur because these cameras are recording at a finite exposure time. You have lots of data. They need to be stored, and then they need to get to the storage hard drive or whatever first. And then when you want to look at the scene, you need to decode your stream quickly and randomly, which is also something that in the beginning I thought we didn't have to worry about, because this is so obvious, and there are so many experts in this area that this has been solved, and we just buy something off the shelf, right? I mean, that being computer graphics, my students are computer science majors. They don't like to tinker with hardware. They don't like to use soldering iron. They burn themselves. They love to program, but this is something that they are not really into. And so you look what's available on the market, and you find out essentially nothing. I was very sad to hear the news that Nokia discontinued the OZO. I thought that was something really worth pursuing. They will have had their reasons. Google made a fantastic advertisement with their camera, but you cannot buy it. You have to build it yourself. They just give you the blueprint. And what they don't tell you, and what we couldn't figure out, we asked the GoPro how to synchronize these cameras. If you know, please let me know, because we haven't figured out still. Then Facebook has this ball, which you cannot buy. This is something I found on the internet. The Eye, which looks great. It's just that it's custom made. You have to call them up, and they give you a price, maybe starting at 13,000 and going up to 50,000 or something. The only thing that I've found that you can buy is this camera by Samsung. They are actually giving a price on their webpage, which is $10,000 or $10,500, and I think they're selling it in the US. So if I were to import it to Europe, then I would have to pay duty, and so that's even more expensive probably. So right now that's the one that I found. Maybe there are others out there. But still, if you want to have high quality panorama video recording heads, it's expensive and it's not easy to come by. So what everybody's doing that I know is they're building their own thing, and that's what we did. Thank you, 3D printing. We also used the GoPro cameras, 9 of them, and unfortunately we couldn't figure out how to synchronize them correctly, so they're starting whenever they want to start, and then we make sure that we find how they are related, but it's not always on the same time. However, input resolution is pretty good, and that means output resolution is also decent. Ideally, we would like to have this double. We would like to have 22K, 360 round. But for the time being, this is what we could afford. Because we don't only need one of them, we need 3 of these heads. I said in the beginning that I think what is very important in this about immersive reality is that you are able to move your head at least a little bit around it and have the impression that you have ego motion parallax. So with a single camera head, you cannot really get that. Maybe with the Samsung thing, I haven't looked at that yet. But our idea was to use 3 of these panorama camera heads and just assemble them in a triangle. So you see here the 3 recordings of the 3 cameras. And you see always the other 2 cameras in the one camera's view. I think you get a feel for what this looks like. And then, given these 3 panorama videos, we want to be able to render any viewpoint that is positioned in between these 3 camera heads. So you are able to move within this triangle, and maybe a little bit extrapolate if you go outside, but not too much. And then by defining or deciding on the baseline, how closely are you spacing these camera heads, you're more or less deciding on the field in which you can move your head, or maybe even your body. Of course, if the cameras are far apart, that then increases the challenge that comes next, which is how to interpolate between these 3 camera positions, of course. But so this was our idea, and we get rid of these images of the cameras by just filling that in from the other cameras. So that is okay. One thing we had to think about was that these camera heads are, of course, not aligned perfectly, right? You just put them on the tripod, and then you make sure that they are more or less level, but of course they're not pixel exact level. So you end up with recordings that look like this. These are 2 of the 3 cameras, and you see this is an atrium, and you see that the floor is kind of wavy. So you want to correct for that, make sure that everything is here in a line, and then what you do is you rotate the whole thing so that if you look at infinity, the same point here shows up at the same x position. Okay, nothing big, it just needs to be done. And it's something that is costing time, because what we want to do is now we want to use these sequences, and we want to render new views. So let's say you have your 3 camera positions here in blue, green, and red, and for any position within between, you want to create the interpolated image. We are not there yet. We are working on it. And the idea that we want to pursue is something from image-based rendering. This is all image-based rendering, of course, because we only have images. And the idea is to use depth and correspondences together. So if you have, and this is from just conventional cameras that are recording an object from different viewpoints, but with the panoramas, it's essentially the same thing. It's just 360, and the geometry is a little bit more complicated. We have the depth, and then we have the correspondences, and we use both to then create plausible in-between images. So we get around popping if you're recording at different moments in time and something is moving, or blurring. First of all, yes, we have to come up with the correspondences. We have to come up with depth. So this is computer vision, and computer vision is great for a lot of things. It's not so great, I find, if you use their algorithms for rendering things again, because in computer graphics, only a few pixels will destroy the impression that the scene is moving naturalistically. Even if they have only a few outliers, the rendered image with that wrong depth at those few points looks horrible. So we have to come up with our own, or at least altered algorithms based on what computer vision has been doing, but then make sure that we either don't get outliers, which is almost impossible, or how to deal with outliers, detect them, mask them. And you see here a couple of examples using this algorithm where we use depth estimation and correspondence estimation in unison. Let me just... So what you can do now with the... so what we had here was just 70 cameras around this statue. So this is the lion, the Braunschweig lion. Henry the lion, sometimes in the 1200s, I think, was a famous duke of the town. He founded Munich, by the way. And so at that time, Braunschweig was like a major capital in Germany. Has changed since then. But you can now use different arrangements of cameras and get something out of it for the interpolation. Here, this is from a paper by another group, and they provided us with their footage, and we could just do our algorithm on the data. It's not perfect. You still see some small mistakes, but it's better than what has been there before. And so here's another example, just with the smartphone cameras recordings. So having both available, correspondence and depth, helps because you can make sure that outliers in one or the other can get masked and can get corrected. Okay, so the next step for us will be to now look at these algorithms that we developed for this scenario where the cameras are looking in, which is the standard image-based rendering scenario. You have a stage and you have several cameras looking there from different directions. Now we have 3 camera heads looking outward, and for objects that are now approaching, for example, these 3 cameras, we need to be able to render also in between these camera positions. Outliers are still a big issue, of course. Areas that are not seen in any of the 3 cameras are difficult, of course. So you need to come up with something that is not visually salient, but has to be masked in one way or another. You have holes in there. You have these 3 video streams that you have to handle. You have to access the data quickly, and then, of course, render quickly from that. So the rendering algorithm cannot be too complicated either, because you want to be able to react to when someone is moving the user is moving his head. The rendering algorithm has to create the new view within, say, no more than 30 milliseconds. Less than that, actually. So you need to get the data, the right data. You have to do all the warping and so on. Temporal coherence is another thing, because going from one frame to the next, if the depth and the correspondences, say, are not temporally coherent, and you just do this on a frame-by-frame basis, you will see that as well. You will see jumps, and that's very annoying. With that, I thank you for your attention, and I hope that you will help us work on this and make this big thing a real big thing. Thank you.
All right, thank you very much for the very interesting and inspiring talk. Probably we can get 1, 2 questions, and remember that there will be also a panel in the afternoon. But if someone wants to ask anything at this moment, or we leave the questions, Markos is around also in the premises, so you're welcome to approach him and discuss more informally about all these approaches, methods, technologies that were presented. Okay, thanks once again.
All right, thank you very much.
By the way, we have an also, if you want to rent it, we are also offering rental services. One, but operational, working. All right, so this is my short presentation about CIVIT, and we wanted to call it CIVIT 2.0 because of the new settings, but then my colleague, Yuan, actually suggested that we should call it CIVIT 2.018 because we have nowadays slightly better version, and this is the state of the center in 2018. I will start where I finished my last presentation 15 months ago. So we are having the Tech Day in the other room, in S1, and in this stage it looked like exactly this room. It was an auditorium, quite well old auditorium, and I was showing plans how we are going to transform it. Today you can go and see how we have transformed it for a few months. In April and May, we are still in the construction thing, and we had to urgently empty the 2 wings of Tietotalo because we had to provide them to return back to Syk. And then we had to pack everything, a 3-ton heavy light field display, a robotic arm, and all other equipment which stayed in a storage room before we were able to get into the new premises, which were set during the summer, and then we spent some more time during the autumn to be able to now reopen it with its full capacity. However, what hasn't changed is our service portfolio, which I will briefly repeat. So our services are like focused in 3 groups. We want the center to be an active unit in research projects, both with academic and in industry partners. Then we want to be in contact, in close contact, interaction with our students. So we are looking for our future talents to provide them, to help them to have hands-on experience with modern equipment in order to develop the next stage of immersive visual technologies. And then we want to use the center as a platform to interact with the related industries, related companies in Tampere. You know Tampere is like called the imaging center of Finland, maybe in Europe. And then we want to provide services for all these companies dealing with imaging and visual technologies. A few more details for research. So any type of projects like commissioned research from industries or collaborative research on European level or with a group of companies, or academic research exploring more fundamental questions and challenges. For example, only yesterday we kicked off one big European training network called Immersive. Immersive comes from immersive visual technologies for safety critical applications. So we actually wanted to go away from the normal use of such things for entertainment or gaming, and to explore how to use them, how to find the best use for tasks where people have to make decisions, critical decisions, where safety is very important. So how to minimize the risks in cases like operating heavy work machines in harsh conditions, like in snow, in fog, in all these things where visibility is not good, but the operator has to have full situational awareness. Also in control centers where operators or people making decisions are fed with a lot of data, a lot of visual data, and they have to find a way to interpret and to make decisions also based on this. So in this project, we are dealing with imaging technologies, but also with their implementations into embedded systems and data communications, how to reach the use cases, and also using the help of social scientists dealing with cognitive and organizational psychology in order to elaborate on the study of the human factors while adopting this immersive visual technology. So this is an example of a training academic project on a European level. We continue our other network called European Training Network on full parallax imaging. This is more focused on light field imaging, from the stage of sensing and content creation, then going through computational imaging and compression, and eventually to vision and visualization. One method which we have been constantly promoting and which was actually developed in a previous European project, Pro-Lite, is how to reconstruct the whole light field just using a sparse set of images. So if we put our cameras, and they are not very many, so we can use 5, 6 cameras which are not very close. So we want to be able to reconstruct the whole intermediate views, like the whole light field, any arbitrary ray which is within the field of view of the camera rig. And then what we are trying to do is to look at what is called epipolar image, epipolar plane image. If we stack all images, and then if we make a slice, we'll see something which is formed by stripes, by lines, which show each point in space is transformed into line, showing the disparity or the corresponding trajectory in this epipolar plane image. If we have infinitely dense images, then we'll get these perfect straight lines in the continuous case. If we have only a discrete set of cameras, we get this type of lines which are broken. And we want to impinge these lines. If we are humans, we can easily see how the angles are formed, what are the directions of these lines. So we want to actually develop the algorithm to be doing the same, and we are doing this in a transform domain. We are using something what we call shearlet atoms, which are located directional multi-scale atoms, which are able actually through an iterative procedure to find the way of the lines and to fill the gaps. So it is maybe better just to show it. So we start with this rough approximation, and eventually after several iterations we are able to reconstruct this epipolar plane image domain. Here the blue lines are the given camera views, and we are able to fill everything within, which if we show this like in terms of views. So we start with 16 views, which are quite sparse, and the ground truth is 512 views, and then we are getting the reconstruction of 512 views, which is pretty the same like the ground truth. And this is totally based on images, so we don't use the depth, we don't estimate the depth, we are using only implicitly through the epipolar plane representation. We invite you to see actually our content rendered on this wide-scale light field display during the demo session. And specifically, we are going to show scenes composed of semi-transparent objects, where depth-based rendering methods would be inferior, they would fail, because you have to assign a depth to each pixel, and in semi-transparent kind of scenes, you cannot do it. Back to our 3 group of services. When we work with students, so this can be done through thesis work. We can formulate it together with companies working in having an interesting program. We can organize seminars for students. We want also to work together with Damla, which is another platform where projects are formulated and students are attracted to work in teams to develop such company-defined projects. This is an example, for example, of a MSc thesis. So Ugur Akpinar worked on lensed array-based techniques for 3D scene capture and display, And this is the display part, where we use so-called super multi-view display arrangement, an arrangement where one can use a sheet of small lenses. They are so dense that they create many directional views. And the use case is a transparent head-up display, which can be used like in a windshield. So you can see the arrangement, it is actually able to show the image few meters away from the windshield. In this way, the driver or the operator of the work machine does not have to refocus. So this helps very much, because in the current head-up displays, one has to look exactly at the display, change the focus. The focus is otherwise more toward the driving scenery. And in this way, we can show this information further away. Plus, we can use it as it's essentially an augmenting display. We can use it to tag, for example, objects, things of containers in cargo terminal or something. So you can see this prototype. We are looking very much to continue developing it, and we have been looking for industrial partners to do it and to commercialize this successfully. The third group of services is what we call platform for partners. So we like to establish partnership with companies and to provide either user experience services to test the user experience for different immersive and VR contents and applications. We provide specific data sets for tests, for benchmarking. They might be annotated, so we have such data sets for VR and for light field method development. Our rental services are in place, but this is not something that we want to very much specialize, but still, if we have this expensive equipment, we are happy to rent it when it is not in use for such purposes. We have also this small type of project, we call it proof of concept service, where we can do something quick just to create some prototype or demo or pilot, which then can go to full-scale research project. This is an example of some of the equipments. I think I was showing this in the previous time. At that time, Ozu was a big hype. It is still a very good hardware, so we are happy to work and to create content with it, and also to compare with the other VR solutions. So we have also other type of VR cameras. Planoptic camera, like by Raytrix, different time-of-flight sensors for measuring depths and creating range images. We can do customized camera rigs with multiple cameras or multi-sensor arrangements, combining color with, for example, time of flight. We have this infamous robotic arm. This is one of the things we haven't fully installed. This is the shooting from the opening event here. At this time, we had it properly set. Now we have to do the painting. It's actually, because of it is heavy and import, like it has safety issues. We have to make it sure that it works properly, but at some moment it will be in full use. However, what we now have fully operational is this omnidirectional treadmill, or the OmniDeck, delivered by Omnifinity, our friends from Sweden, and they are going to show it. And please go and try it, because what Richard claims, this is the missing part between virtual and reality. So you can walk, you can get also the response of your other system, the vestibular system, to be fully immersed. It's a bit challenging, and as it is a research device. However, it is exciting. A high quality LiDAR is another latest procurement, and we are going to show you how we are using it, getting the data, getting the point cloud, transforming into 3D scene representation, and putting it into a VR application. We have a kind of business model, so especially for the platform, this is what we have been advertising. We like to have the companies which want to use our services and want to be in interaction with us, eventually to establish this industrial academic partnership. We want to have them as a partner, and we request some small partnership fee, which is 360 euro per year, in order to get access to all services and to rental and other type of use of the center. Also, we are looking very much, and we are proactive in establishing strategic partnership with companies in industries or associations. Like FIMA is one example of such a partner, the Forum for Intelligent Machines, where we can be more like tailoring our research to their needs and developing more specialized tours. So I think that this is going now more to the end of my talk. I had some, let me check, a few remarks. Yeah, this is the acknowledgement actually page. So of course, we recognize and acknowledge the first investment done by the Academy of Finland, this first 1 million which came in 2014 to start all these things. And then it was, of course, co-funded by the university, Tampere University of Technology. I would specifically mention the role of the current Vice President of Research, Jarmo Takala, then the person responsible for all infrastructures within the university, Pekka Savulainen, Anu Juslin, who has been supporting us from the beginning, from the proposal till all these bumpy arrangements. Henry Vinikainen from the support from the maintenance services, who was always responsive to all our craziest requirements about the spaces here. I quickly made these notes. Maybe I'm missing someone. Also on the faculty level, I'm very thankful to the support of the Dean, Mika Grunström. We are like part of the laboratory of signal processing. It used to be called Department of Signal Processing, now led by Joni Kamarainen, then Pirkko, Virve, Kari, Jari, Yuli Hietanen have been always very helpful in the arrangements. And we are part, like research-wise, we are a part of the signal processing research community led by Professor Karen Egiazarian. I owe my grateful acknowledgement also to Fondon, the consultancy company we work with to properly set and describe the portfolio of services, Raka Creative to establish the initial network of CIVIT and its partnership. And as they usually say, last but not least, my research group, 3D Media Research Group, with the motto of immersive visual experience empowered by signal processing research. So many thanks to Olli for all these settings, Robert for the overall supervision of the center, Sergio for setting up all web presence and visual presence, Felipe for setting the streaming, Suren for the arrangement outside displays, Laura for registration, taking care of demos, Jani also for and Ugur for the demos and so on. So very nice, very energetic and motivated researchers. Okay, sorry, I thought I fixed the sound, but unfortunately it came a bit loud. Still, we are also trying to promote this type of animated logo of the center. And thank you very much for your attention. So we have our next presenter. So thank you very much. So at some point I was worried in the beginning because I couldn't meet you, but
I came a bit late.
Fortunately everything is okay. So I'm proud to present Urho Konturi, the CEO of Varjo. This is a Finnish startup developing the next generation of virtual reality displays. They are newly developed bionic display, lets you see imagery as clearly as you see the real world. And Urho has experience as a software developer for a decade, led visual side of operating system, N900 at Nokia, then being in labs in Nokia and Microsoft, and currently developing VR hardware development, founder and CEO of Varjo. You are very much welcome.
Okay, thank you guys. So I'm Urho Konturi. I'm the CEO and founder of Varjo, as just introduced. And Varjo is a Finnish company which is roughly 16 months old and creating a revolution in the computing space. I'll tell you in a moment how that's going to be happening, but we'll just quickly recap some of the previous fundamental transitions in the computing space. So first of all, you had the text-based computing interface, which came at the end of 70s. And that, of course, transformed the computers to be actually usable as interaction devices. The next phase was the graphical user interface that was introduced in the 80s that actually transformed much more fundamentally because now the computers were possible to be used by everybody. And of course, that came from having both graphical user interface, but also the input device, which was the mouse. And now the third revolution in the computing was the mobile computing revolution, where everything that you could do with a computer, you could do with that small, tiny little thing which is in your pocket. Right. Now, of course, mostly that really came from Apple, which made that huge input transformation into the mobile devices. It wasn't only a mobile phone, but it was an actual device you could do everything with because of the touchscreen. And they were the first ones that actually made it in the right way. Now the fourth transformation in the computing is, of course, the immersive computing transformation, which is now expanding the capabilities of the interaction tremendously. You're not interacting only anymore with a small device, but everything around you is the interaction medium for you. And of course, what is interesting is that all of that will be, of course, manipulated by the graphics. So the hope, of course, of the immersive computing is that it lets our imaginations loose completely. Everything is possible with the immersive computing. Now, of course, the interesting thing is that it needs to be good enough, just like it has been in all of the previous paradigms, until it actually becomes a successful platform. And one of the fundamentals for this is that when you work in the immersive space, you need to be able to act efficiently in there. And one of the key things about that one is the resolution. You need to be able to see the things in the same way we do in normal life. And we had just a little bit more than 6 months ago, Jason Paul, who is a GM of VR strategy at NVIDIA, was saying that it would take us roughly 20 years to achieve human eye resolution in VR. So you're kind of like looking that there is going to be a pivoting point somewhere in between when it becomes interesting. But from this status point of view, it's not going to be happening anytime soon. And now Jason Paul is the kind of guy who is looking at 100 miles above the landscape. He's from NVIDIA, focusing on the VR. He knows what the graphic guys are doing. He knows what the CPU manufacturers are doing. He knows all of the display manufacturers. This is his opinion about the state of things. Now, there are many reasons for that one, why it's difficult to reach that human eye resolution. One of those is, of course, the display panels themselves. The second one is the data throughput that you need to actually shovel all of those 100 million or 200 million pixels each eye to the display, 100 frames, 200 frames per second. But of course, then you also need to have the compute to be able to compute interesting content into those. So it's a difficult equation overall. And when we look at the VR of today, which is still the high-end VR that you can actually buy from the shops, is running at roughly 1 megapixel per eye. whereas the human eye in that same 90 to 100 degrees field of view is running at over 100 megapixels. So the gap is, then of course, there are other factors as well. You want wider field of view, you want much more dynamic range to the pixels. It's an almost infinite work to be done in that domain. On solving basically the first of these problems, which is the resolution. We call the solution for this one bionic display because it's inspired by the human biology. So how our eyes work is that we're looking at one place at a time in the full resolution, and that's like a tiny piece. It's like a thumbnail at your arm's length. That's the size of our accurate part of our eyes. Now, of course, what is interesting is that can we actually make displays that could produce the sharp detail only into that place? And this is what we have been working. So taking that innovation from the humans, where it was in the making for a couple of 100 million years, and trying to make use of that one. And now, of course, first part of our technology is that we have been building our own eye tracking system, so we know exactly where you're looking at. Where should we create those high pixel densities? Then we have been working on the part that, how does it then work? You need basically 18 degrees, which is the macular. It's basically this medium resolution area of the eye. You need to be able to cover that area so that you're actually able to create the feeling of full resolution wherever you are, and you need to be able to move it. But when you do, the result is that it feels like everything is actually in the full resolution. The method we chose to implement first, so we, of course, innovated this idea over a year ago. Then we patented basically all of the ways of achieving that one. And we chose the shortest route for the first product, which is a very much an engineer solution to the problem. And it's basically to have two displays. One is a normal VR display, which are perfectly fine for our peripheral vision, where we're basically having 10,000 times less density of the cones and rods than you have in your center field of view. So today's VR, which is like 100 times behind the full resolution, it's perfectly fine for this 10,000 times less of resolution, right? So we're using that one in the background. And then for the high focus area, we have chosen to use Sony's micro OLED display, which is running at very high density. It's also very expensive. Why you cannot make just a very large version of that one. But we combine these with an optical combiner, which is a fancy word for half transparent mirror. And that allows the user to see at the same time both of these displays. And then the first method of actuation is that we just tilt this glass plate ever so slightly, and then the reflection changes on the surface of it, which then creates the full immersive human eye resolution. Now let's take a look at some of the examples we've been taking. So this first one is an image we took from Oculus CV1, which we thought around a year, this is about a year's old image, it was the best high-end headset in the market. So when you put the headset on like that, what you're really feeling that you're seeing is a display in front of you, which is magnified. You can see the sub-pixels, you can see the individual red, green, and blue colored pixels in there. You can see the black space in between. This is not far from the feeling that you actually get when you put the headset on. Now, when we look at the same thing with the Varjo headset, it's a very different image you're getting. So this was taken completely apples to apples comparison. So SLR with the same optics, same place, same field of view, same everything, same lenses, absolutely the same. And the difference is huge. VR of yesterday, VR of tomorrow. Yesterday, tomorrow. Anyway, so let's take a few other examples as well. This one is from a demo we could actually show today as well. It's basically an interior scene that we bought from Oculus store. We added a bit of detail to the textures. This is again from Oculus. And then the same thing with our headset. Now, of course, you should be starting to get the grasp of what you can actually achieve with this technology. Now, these are examples of architecture visualizations, not done very elegantly in the quality way. You can see that one. It's still decent. You can appreciate the space. You can appreciate the designer's decisions about the brick walls, about the textiles, about lighting. All of those you can evaluate really well. See the space, which is something that you have been able to see before, but you see the detail at the same time. Okay, very good. Another small comparison example here that's also possible to be demonstrated. It's a simulator scene. This is from Bombardier Business Jet. And again, with Oculus on, at the place where the pilot is actually sitting in, you cannot make sense of anything in your scene. You cannot read the map. Maybe you might be able to use slightly the coarser parts of the map, but you cannot make any sense. What are the buttons over there? What are these radio control panels saying to you? And when you're really trying to use simulations for training, what it's all about is being able to actually work on the instrumentations. This is what the civilian simulations are all about. Then in military simulations, you might have additional drivers as well, but still, you always have to actually work with the machine you're inside. Now, again, looking into what this becomes with the Varjo headset, again, quite a different view. So suddenly you can actually read all of the labels, you can see the map, and the radio controls with the right angle, you can read those perfectly well. This is something that we'll show to you guys after 2 p.m. when the demo portion starts. Good. Then just taking a look at some of the areas that we see are going to be the first adopters of the high quality VR revolution. And one of the reasons why this is going to be a limited set is that to achieve the human eye resolution, we decided very early on that we don't want to do a consumer price point headset, so that we can get rid of the limitations you have by choosing consumer grade hardware components. And this is something that some of the founders have been working for years at Microsoft, Nokia, NVIDIA, Intel, working on consumer grade products. And in all of those, you had to do compromises that never made sense, typically to the technical people, but made the perfect business sense. You need to be able to reach certain price point to be competitive, otherwise people don't buy your device. And that's the reality of the consumer products, but it's not the reality of the professional products. So if your device costs 5,000 or 10,000, it typically doesn't make any difference for larger organizations. If it's 100,000, probably for many people, it wouldn't make a difference. For example, in the simulator space, we're discussing with many parties about them replacing existing full cockpit simulation systems with our devices. And these are typically north of 10 million each. And they take almost the space of this auditorium for a single simulator device. So to replace that one with something smaller and much, much less expensive, it's a very trivial decision to make. I'm not saying that you can fully replace those, but you can replace maybe half of the time spent inside those. So then that one existing full cockpit simulator you have, it's much more valuable because you can run more people through it over the time. Okay, so the first companies that we contacted in the March of last year were basically some of the CAD manufacturers, and we were asking from them, okay, we believe overall that industrial design is a really interesting area. Architecture is maybe also an interesting area, and engineering. So how do you feel about it? Who should we start working first in this domain? We're a small company, and they said that clearly you need to go to the car makers because they're the most demanding users of VR. So then we went ahead, we discussed with basically all of the car manufacturers in Europe, And I'd say like 80% of them have been using VR for over a decade, some for 2 decades already. Just trying to go by with first the military-grade VR headsets, then some of the cave systems, then these consumer VRs. And it was really enlightening that every time we had their industrial design head, putting our headset on, it was like, wow, can we have this tomorrow? So it was like, literally took like 2 seconds for them to realize that their world has changed fundamentally. Because for them, it's all about improving the speed of the design process from the idea of a car, how fast can we actually move to the production of the car. Because then you gain a competitive advantage. And being able to get rid of appearance models, which these companies need to do now. So appearance model is basically either an exterior shape of the car that has been CNC milled, glasses have been made for that one, it has been painted, it has been varnished, and only then the designer comes, looks at the reflections and goes, yeah, it doesn't work, this curve doesn't work, and then it's back to changing that curve and waiting for a month for the next appearance model. So imagine that you can actually do that one in VR by changing the curve and seeing the result instantly. It's a huge game changer for all of these guys. But anyway, industrial design overall, really interesting area in the future for the VR use. You can see the design instantly lifelike, exactly how it's going to be. Training and simulations is also another really powerful area for this one, as described for the civilian aerospace. In the military area, you have plenty good simulators, but you typically don't have enough of those. So let's say that you would want to actually train a squadron. Typically, even in the United States, you don't have the simulator capability to do larger formation flying trials or anything like that. So let alone in smaller countries or in the civilian space. Then even extending this one, we've been discussing with hobbyist simulator users. These guys typically shell easily 10 to 20,000 in their rigs, where they desperately try to use consumer-grade VR or then having like multiple monitors around them to get a sense of freedom. Okay, then architecture and engineering is like a really interesting area. In the architecture side, you would imagine that VR is really used as a tool for the architects. The sad reality is that today it's not possible because the flow from the architecture CADs to the VR is too long. It typically has 5 steps. It goes first through a converter, then it goes through Autodesk Max or Maya. Somebody does texturing to it, material changes. Then it goes into Unity or Unreal. Some additional work gets done, and eventually it ends up in a VR headset or similar. Of course, the hope is that the architect of the future will actually be inside the building she's designing. And what she's seeing is the realistic form of how it's actually going to be. Then she makes changes, and the world changes around her. It's going to be creating a completely new point of view to the architecture process that, of course, I would hope that ends up in more interesting and more applicable architecture. But this is also, of course, on the engineering side where the volume, the market is much bigger. But when you think about a skyscraper, you typically have a team of maybe 5 to 10 architects designing that one. Then it's very expensive work, obviously. They make 10 to 15 appearance models that are, again, going to be exact miniature versions of that one. And we met some of the largest architecture agencies in the world that they were saying that, okay, if we had in our previous project your headset, we would have been able to skip 7 of these miniature models out of our 10, and we would have been able to save 3 months of time, which was like, wow, insane, just insane. But the engineering is, of course, much bigger area. So when you design a building as an architect, you have 5 architects, but then you'll easily have 200, 300 engineers actually doing that building, going through all of the support structures, all of the cabling, making sure that you have the plumbing, all of those in place. And even for those guys, it's really valuable to be able to evaluate your ideas in the real structure. So again, we hope that even these guys would get a less technical point of view, but also a bit more practical in some cases, so that you can jump between these abstract and very concrete. And then the last area that we see as the first stage, as a really interesting area, is immersive entertainment. So we just visited all of the Hollywood studios. All of them are working on location-based entertainment centers, basically trying to leverage the asset that they have in the movie theaters and trying to make it so that they get people to go and watch the movie and then get a really deep emotional connect through the immersive experience after the movie. Of course, what they then do is that they charge you twice, which is more money for them. But really, what is the driver is to make it so that people get that emotional experience, and then they will tell their friends, you need to go and see it in the theaters, because that's the only place that you can actually get the full experience, and you must go for the ride after that one, because that was just phenomenal. And of course, they get so much more money from each customer when they go to the movie theaters instead of watching over Netflix, where they get next to nothing. And then if you can double that, great. If you can increase the people going to the movies, great. So it's seen as a really valuable area. And of course, the key for that one is that you need to be able to experience something that you cannot experience at home. So again, these guys are very much interested in spending a little bit more on the equipment to make it so that it's as perfect as it gets. So just telling you guys that these are basically some of the reasons we chose these 4 verticals as something that Varjo is going to be targeting in the first wave. And so since we basically came out from Stealth last June, we were approached by, I'd say 200 out of the Fortune 500 companies, and plenty more of smaller companies. So we have been doing now some cherry picking for the companies that we're going to be working with, because how we believe at Varjo is that to be able to actually do a perfect VR headset for an architect, we really need to be working with the architect, because we don't know their requirements. So we have now created a beta phase where we give out our headsets to some of these interesting companies and ask in return, please use it for a couple of months and tell us everything which is good about it and everything which is bad about it. Give us recommendations how you would like to change it. And we still build in the flexibility into our R&D to make it so that we can actually make use of those ideas. Seems to be very difficult thing to actually achieve. Okay, then of course this is the unit that we have basically with us here. It's a Varjo early prototype, and we're now have been shrinking it considerably to make it so that we will have a beta prototype available to these partners in April. Now, in this phase, what we have been doing is that we have been spreading some of these units to our partners at AMD, NVIDIA, Unity, Unreal, and Technicolor. All of these are technical partners. So with AMD and NVIDIA, we're trying to make sure that the rendering pipelines and the latency can be kept at the minimum. We're able to use direct modes on both of the chipsets and so forth. With Unity and Unreal, of course, we're providing plugins so that the next phase of companies would be able to make easy use of converting their existing VR projects to use our headsets. And then Technicolor is working with us to do the color grading, so basically the color accuracy of the headset. So of course, for a professional designer, if you see a shade of pink, you really want to trust your eyes that it's going to be the same shade of pink when it actually rolls out as a physical thing. So having color accuracy is fundamentally important for us. And we partnered with the best also in that domain. Then on the verticals that we chose, we've been now working with the Volkswagen group of 17 sub-brands. They have like Porsche as one of their brands, Lamborghini as one, Volkswagen, Audi. But then we also partnered with BMW, who have been like phenomenally good in their use of VR over the years. Really interesting in that domain. On the training and simulation side, we've been now working with Airbus, both in their airplane simulation side, but other kinds of training that Airbus does. And they do, it's again a huge company, so they do a lot. Bohemia Interactive is more from the military simulation side. They've been, I think they're the largest simulations company these days in the military space. And then Saab, who are our very dear, close by friends from Sweden. Big heart for those guys, and we're trying to look at a bit more explorative things with those guys because they're so close by. With CERN are the makers of the Large Hadron Collider, and it's like, I don't know, it's probably the largest machine in the world these days. And what they do is that they do maintenance to that one once a year. And what happens is that there are two huge trains that pull apart the Large Hadron Collider, and then roughly 1,000 engineers rush inside there, and they do the maintenance for the whole year. Now, to prepare for that one, because it's a one-day break from use of that facility, all of the year's maintenance must be done in a year. So they plan a lot, they train a lot ahead of time so that you can do all of your tasks fast enough. And with today's VR, if you would be doing those training cases, what you need to do, let's say that you're an electrician, you need to put your head like right next to the cables to be able to understand what is this cable, what is that cable. Instead, with our headset, you can actually train in a situation where you're working at the distance that you would actually be working in. So it's going to be really interesting. Also, they have data, and that needs to be visualized in many situations, and we are working with them to see how can we actually do insane visualization of those data sets with our headsets. Celent Group, it's the largest construction company in the West Coast. And then Trimble is the largest building information model software company in the world, but they also do almost all of the laser scanners used in the construction yards that create the 3D model. So one of the areas, of course, in the construction business is to make sure that when we had this plan, how was it actually implemented? So you do a scan and then you run comparisons, typically automatically, that compare that did all of the things where they actually put to the right place, where they were supposed to be. So really interesting domain. On the side of the immersive entertainment, we're now working publicly with 20th Century Fox, which is, of course, owning really interesting IP and was now bought by Disney. I don't know what that means in practice anymore. So need to go to the States and discuss with them what's going to be the mode of collaboration, I would say, after next summer. Typically, when you do these big acquisitions, nothing happens, nothing changes instantly. But what does it mean in the longer run? Magnopus makes actually most of the immersive cases for the companies outside of industrial light and magic. So it's a really good partner for us because they know how to actually make use of the VR. They don't only own the actual movie assets and the brands and so forth. And Technicolor is, again, one additional partner. We're working also with their experience center, which is in LA. It's a really nice place if you happen to be in LA to go to. They have both motion capture studio there, but they also have a segment where anybody in the public can go to and experience the latest in, especially in the immersive technologies. Okay, so on the Varjo side, we have started the early access program now at December last year. We're shipping prototypes during April this year, and we'll be launching our first professional product at the end of this year. And of course, It's a very aggressive schedule. Would like to say that who is our manufacturing partner, but we don't have the public agreement about that one yet. Anyway, we're basically using our existing mobile phone contact base, so will be manufactured by one of the largest ODMs in the world. So just recapping quickly, Varjo, founded in summer 2016. We are right in the center of Helsinki because many of our engineers are coming from Tampere or Salo, and we want to be close to the railway station for that reason. But still, it's funny that inside, like right next to Stockmann in the Helsinki city center, we are building the most advanced VR headset, doing the R&D. We have really nice laboratories there, and it somehow feels very weird. Typically, you have those in facilities like this, for example, where you do that R&D. We do it in the city center. We basically started the company with less than $1 million in our seed funding, and I always had the premise that you shouldn't start a hardware company unless you have at least $1 million, because you just cannot buy any of the equipment if you don't. We started with a little bit less, but Tekes came to our help almost instantly, so we were able to go beyond that like fundamental limit. Then I think the official closure was actually in September when Equity Ventures closed a deal with us, and we got the Series A funding. For many of the companies, this would be called more like a seed funding round, really. But anyway, it was basically enough for us to go through the R&D phase. And now we were basically helped by Tekes, so Finnish Innovation Fund, with their largest investment ever in a Finnish company, and really happy to be working with those guys as well. And it's funny, we are also working with European instruments, so if you guys ever do work on trying to raise funding, and you think that you might actually get something more from EU. Some of the people here call it a European lottery because it's so difficult to actually get money from Horizon 2020 or similar type of funds that EU has. And it's for a reason, because it's like 2% of the applications are actually funded. And making the application is very tedious process. Reporting is very tedious, completely unlike what it is for Tekes Finnish Innovation Fund. So if you have a great idea, it takes a couple of meetings, and the bureaucracy is writing a short application, filing that one. It goes beautifully if your idea is good. So, and then what you need to do as a company, you need to follow that basically how many hours are you actually putting to the project. So very trivial, almost no bureaucracy, and I find it funny that some of the people somehow get to complain that Tekes is creating too much work for them, because it's tiny amount if you compare to these European instruments or so. And so very much recommended, if you're kicking off a company, do go to Tekes very first thing and work with them how to understand what is the value of your business idea. So anyway, I just love those guys. I think that was the content of my presentation today. So Varjo is really working on the most advanced VR headsets in the world. We happen to be also working on the mixed reality. So maybe as a bit of background, our company was formed with the premise that to actually achieve a great quality mixed reality where you cannot tell apart what is real and what is virtual, the best way to achieve that one is not with a HoloLens type of optical see-through device, because then you have two mediums that are created very differently. We had been working with the HoloLens team a lot and in the past, and the video see-through, where you use very high quality video cameras to capture the world around you, you send that to GPU and you mix this digital version with the real and the virtual together, and then show it on a display. Now suddenly both of those mediums are on par, and it's the thing that in the movie and gaming space, it's called a Fidelity Contract that you create in the beginning of any kind of movie or game experience. It's basically setting the level of your quality. And then you're never allowed to break that quality expectation. That's why you shouldn't ever go to higher textures for a certain part of the game and then having lower, because that creates the discontinuity in the user's head. Now, as opposed to using the method where you put both of these experiences on par, you're never jumping between these two fidelity constraints. But again, it goes to the place that if you do it badly, it's not interesting at all. It's like just a vomiting experience. Too much latency, too low resolutions, both kill it. Now, for us, we have been working for a long time at Nokia, Microsoft in high quality cameras. We knew that you can actually push the resolution and the optics of cameras to the level where they're roughly comparable to human eyes. But the same thing didn't apply to displays. So this was what actually forced us to work on the display segment. We did contact all of the display manufacturers that we knew from the past, Sony's, LG, Samsung's, AUO's, BEO's, lots of O's, many companies, and we concluded that in their roadmaps, nobody has a solution for the next 5 years that brings the display quality level to an interesting place. So we had to do it ourselves, which I think turned out as a really good strategy for the company overall. Now, in June, we'll be talking more as a company about our approach to mixed reality and creating showcases of that one. Now, we've been working basically since day one on the mixed reality as a company, and this display part and this VR part was more of a, almost like a sidetrack for us. It just makes perfect business sense. But we believe that in the future, the immersive computing is not only this isolating experience where you're in the full virtual reality, but it's actually combining the world around you and the virtual world together in a seamless way. So that's it for me. I'm fine taking any questions, depending on the time slot, remaining time. So
we are a bit behind the schedule, but of course, thank you very much for this
Okay.
very interesting talk.
Thank you.
Okay, so we maybe proceed now to the lunch break. And now it's 12. Let's start at 1 o'clock. So let's have 1 hour for lunch. People coming from outside TUT, they got these lunch tickets in appreciation of their time spending here. And we'll continue in 1 hour. when you start presenting, it will have the presenter's mode.
Yeah.
But for some reason, the Explorer pops up.
Okay.
If you see the Explorer pops up, like Alt-Tab
Yeah.
will return you back to the presentation. Because otherwise, you cannot change the slides.
So then I just hit F5 and it starts.
Yeah.
You can also try to put it on the color, like if you move a lot, it might like take static from the or that side.
Is that cool?
Professional.
I can just put it up now.
Okay, so this is now our afternoon session. And it's my pleasure to introduce Richard Guilfoyle, the sales director of Omnifinity, who is going to reveal the missing link between virtual and reality. Richard has a specialized background in international sales for gaming hardware, passion for technical internet marketing, and being an English, he has been living in Sweden for over 10 years and brings a unique combination of a technical IT background with vast experience in international sales and marketing. So we are looking for the next interesting talk.
Thank you very much. As I said, my name's Richard Guilfoyle. God, I sounded quite weird in that little bio there, but yeah, we'll get through this. From Omnifinity, we're the crazy guys that decided to build a massive treadmill just so you can run around in virtual reality. This is one of the first kind of presentations that I'm going to do where I get to say the magic words of, if you want to try it, it's just there. Because most of the time I do this presentation, I don't have it in a briefcase next to me. So I'm going to take you through a little story of how we kind of came to be a kind of a three-man team building this amazing device. We go back to 1952, which is when our mother company in Älmhult in Sweden, which is very famous for one thing, Älmhult. It is the founding town of IKEA and the founding town of MSc Engineering. We've been working on hardware military simulators since the 50s. Now, it sounds like we're this enormous company like SAR, but we're still very small. There are about 22 people who work for this company. And over the years, we've developed flight simulators, main battle tanks, targeting systems, and you can see that's one of our first developed tank trainers there. I love the bow ties. When did that kind of become a thing? When did that leave us? So in this development of building hardware military simulators, how the hell do we end up building a treadmill? Well, its story starts back in about 2009, where we delivered flight simulators to the Swedish Air Force. And you can picture there's a great big room, and you have 8 flight simulators on one side, and the other side you had the special forces sitting there with laptops. And they're running the same scenario, the same mission together. And we thought this was a bit weird. The pilots get all the toys, and they get to fly the planes, and the guys on the ground are playing a version of Counter-Strike. And the thing is this leads to a slight problem that the pilot gets all the training, the pilot gets everything, but instead you're breeding these keyboard warriors. So we decided to look at how do you navigate around in a digital space? How do you navigate around in a game? So we took a treadmill and we took a gaming device. And we really tried to look at how it is to move around. And we tried lots and lots of crazy experiments in trying to take a normal treadmill and try to spin it. You can look at various different examples of hamster balls, I think is the classic idea. And at the end of a lot of money, a lot of investment, we ended up with this, the Omnideck. It's 4.2 meters, if anyone wants to know. You can see it next door. 16 sections, and it's a fully kind of motorized and powered treadmill. During our prototype stage, we kind of got lucky and unlucky at the same time. This is a picture of the Ultimate Battlefield 3 simulator. which was done by the British TV show, The Gadget Show. And this is for the launch of the EA DICE game, Battlefield 3. They decided to build this enormous simulator, which kind of was a bit crazy. The video clips around that week, I think they got up to about 11.5 million views on YouTube. And this is back in 2010. It crashed our website. We had everyone, you know, from the Disney corporations to BAE Systems. I cannot explain the kind of the event that happened around this. Everyone kind of asked me how much this kind of costs if you wanted to build one, and it's an obscene amount of money. It's a bit like trying to buy a Formula 1 car. A Formula 1 car has a price, but you need 40 engineers just to drive the damn thing. And it's the same thing with this. One thing you'll notice is it's using a dome. It's using a projection dome. We were working a lot with the virtual reality headsets, but back then, 2009, 2010, the domes were everything. And then something happened. VK1, Oculus. I mean, that kind of changed everything. Like I say, we were working with virtual reality headsets before, but when the Oculus came in, it kind of, as probably a lot of us in this room today, it just kind of fueled this kind of the second boom of VR. And we really embraced that. We got rid of the dome and we started working a lot more with VR. God, I miss that thing. It was so simple. You could just port any kind of game to that really, really simply. But it didn't get away from one thing that we needed, the tracking. And we were using very expensive motion capture systems to enable the tracking with the Omnideck. And as VR developed, we came to the Vive. Quite outstanding. It reduced, a 45,000 euro system down to an 800 euro box. What they managed to do for the consumers and for a lot of these kind of companies is really kind of change the landscape. I'm going to hand over to my colleague, Peter Thor, who will take you through more of a technical summary of how the Omnideck works and functions. So this is Peter Thor, our CTO. I'm just going to hook a microphone onto you.
That's the next slide.
Yeah.
Thank you. Hi, I'm Peter Thor. I'm the CTO of Omnifinity. Nice to be here. So we're going to have a small and rapid technical summary of the treadmill. We're going to look into how the mechanics work. What are they? How does it work mathematically a little bit? And how do you actually do something for it? How do you integrate something in your daily activities? Yeah, so this is the image we will focus about. So some of you have already been over there and seen it. So based on the tracker of the head, the HTC Vive headset, we capture your position. And that position is then fed into our algorithms to calculate a velocity based on where you are. So if you imagine that you move out from the center to this, towards the middle here, that would represent a velocity of the treadmill. And then there is a motor that drives the treadmill to actively push you back all the times in the red direction. That might seem a bit weird as an observer, but as a user of the actual experience, you are fixed in the same location. So you go out, you stop, the treadmill moves you back so that you have time, you have space for the next step. But inside your head, inside the game, that forward position where you are located and that backwards position, they cancel out. So the forward velocity and the backwards velocity means that you're actually staying at the same location. You have to experience it like any virtual reality experience to actually believe it. The rating of this, roughly 7-8 kilometers per second. It's a steady jog if you really do if you try to increase the speed of it. But this is the low impact floor that we're having here, and we like to focus on the low impact activities for you. And the next step then is, how do you actually build something for this system? Well, we use the Unity game engine and the Unreal game engine, and on GitHub, it's an open source repository for software developers and collaborators. It's a fantastic site. We have a DLL, and you can use that dynamically linked library and add that into your game engine, and that would automatically, with some features and some tweaks that you have to do as a game developer to configure it, it will enable your game or your simulation to communicate with our software, so that you can actually move about in your virtual reality on the treadmill. I believe we do a swap there, and let's let Richard finish this presentation. Thank you. Oh, sorry. I still here.
Don't worry, I'm not finished. We can take after. But I just want to move on to some user cases of other customers that we have. Because it's all very well discussing how cool this thing is and how it was designed and developed. But so probably the most relevant customer, I can't discuss all our military customers with you, no matter how much you force me to drink alcohol. But I can discuss Transport Systems Catapult. They were one of our very kind of first customers. They're based in Milton Keynes, just north of London. They really took a gamble on VR, and they built this lab, beautiful lab, and they've actually ended up creating 2 spin-off companies outside, based purely on the work that they've been working on with the OmniDeck. User interaction testing for large automotive companies. Autonomous vehicles is one of their specialities. And so what they're finding is they're building up virtual towns or virtual cities and driving the autonomous vehicles around, and how the user interaction is. They're also testing how the sensors work and how the sensors are programmed, so that a virtual car can crash into a virtual human without the wonderful nature of a real autonomous car crashing into a real human. The RNIB virtual sign-off. This is one of the most fascinating things, and I remember the day they phoned me up. They said, Richard, the Royal National Institute for the Blind have contacted us, and they've been inside our lab, and they're just blown away, because in there they built up a virtual Milton Keynes, and then inside the Vive they're using, they put special filters on to simulate different eye problems and different visual impairments. And this is mind-blowing. The ability to walk in another person's shoes. They found instantly when, especially with big public buildings, big airports or a shopping centre, that the architects who do not have these problems can walk around virtually in this space and can just turn on stage 5 cataracts, turn on colour blindness, and to really understand how things are. One example I can give you myself is that this beautiful building, as all architects and designers do, they build a beautiful structure, and it's got the lovely furniture and the perfect daylight, and it looks lovely. But they had the same contrast in the floor. It was a dark floor and dark walls. And immediately when I walked in and my sight was impaired, immediately it became really, really frustrating to kind of navigate around this. And it's one of these things that just kind of one of those aha moments. They've now gone on to develop a startup called Thea, where they have mobile apps, and they will be developing, they have partners mostly in America and in Europe, but they're moving on with this brilliant invention. that came from the OmniDeck. Autonomous vehicle, wow, that's misspelled. Interacting testing, again, lots of things with about virtual navigation. They run pedestrian simulators, which is kind of interesting, moving into the town planning. The other thing they're working on is there seems to be a demand, there's a demand to build these amazing augmented reality apps. These are magic pair of glasses that I put on, and when I look at your faces, up comes your LinkedIn profile. Or if I'm walking in a shopping center and I walk past a store and up comes the advert for that store, which sounds like a nightmare to me. That sounds like a dystopian nightmare. But there's this race to kind of get this new technology in front of us. The problem is we don't have magic glasses. There's companies working on these magic glasses, should we say, Magic Leap for one of them. But what they're finding is, again, with this town that's already built in virtual reality, they can build all of tomorrow's AR apps, do all the user testing, get a lot of the testing out of the way. So they're pre-building the AR apps before the AR technology becomes available. And this is a really, really interesting development. And we are really, really, I can say, we're really, really happy that we are here today. It's taken it's been a long, long journey from the first phone call I had from Ollie to get the OmniDeck here, and this amazing lab. And I have to say, I've traveled the world looking at a lot of different labs, and I can truly say that the room next door is world class in the technology and the opportunity. And I just wish that I had the opportunity to play with all of this when I went to school. And that's it. Thank you very much. And if you haven't tried the OmniDeck, then you've got to go and try it. Unfortunately, it will kind of ruin virtual reality for some users, definitely, because you can't go back to that teleportation and that thumbstick and feeling a bit ill. But yeah, thank you very much from all of you.
Okay, thank you. We can get a few questions, if any, or then we'll wait for the panel, which will start after the next presentation. And it comes from Luke Noonan from Rust. And it's entitled Lessons from the Trenches. Luke is a globe-trotting media artist, designer, punk, technologist, entrepreneur, educator, social justice warrior, and noisemaker, co-founder and president of Rust. And a lot of things done for virtual reality. So, yeah.
Thank you.
Thank you.
You got all the right ports there. Cool. So thank you for inviting me up here. It's my first time here in Finland, so it's been a really great trip. So does that work? Oh, it does work. Nice. Yeah, I'm co-founder, president. We wear a lot of hats. I'm also a designer. I was an accountant for quite a long time. Rust Limited. So we are based in Los Angeles, California, and in Bristol, England. And we've been working in games, virtual reality, and other sort of interactive and playful media since about 2009, depending on how you measure it. And we do a mix of consulting work, contract design and development, and our own IP development.
So as we, I'm going to touch on each of those a little bit as we move through this talk. So first, a little bit of history. So this screenshot here was of a project we did called Museum of the Microstar. And I love starting with this one because this was a tech demo itself that satirized or made fun of other tech demos. So it was done as part of a contest that Unity Technologies, who makes the game engine, was holding when they rolled out their new DirectX 11 feature set in their engine. And so you need to use all of these new features to, in the demo, and spoiler alert, we won, and it was good. But importantly, not long after this happened, like within a couple of weeks, the initial Oculus Kickstarter started sending out their hardware. And so we took that opportunity, because we had this just finished project, we still remembered how everything worked, it hadn't left our memories yet. So we ported it very quickly to that hardware. And we learned two important things. First off, that that when you're moving between those sort of platforms, where there's different hardware affordances, you really can't take anything for granted as you move between this. So if we're going to be honest, the VR version of this project was a mess. You got really sick. It was difficult to control. And anyone who's done enough of this work will know that that's obvious. But in our defense, this was still pretty new there. And we weren't some amateurs going into this. We had done work for cave systems. We'd done work with other tracking setups. We were really well positioned. And even with that new hardware still sort of threw us for a loop. The other thing that we sort of got out of this project was that there was, we won a big contest. Thousands and thousands of dollars in prizes. We gave conference talks on it. We got way more press out of the VR port of it than we did out of the initial contest win. And the first version was probably better. It was probably better on a flat screen than it was in VR. So that gave us a real clue. And this sort of started us down this road that has sort of landed us here today. So if we look back at the work that we've done as a group, we see that it covers a wide number of different fields. So just to give you a sense of where I'm coming from, we've done work from board games to high-end tech demos for GPU manufacturers. We've done mobile apps to amusement park attractions. When we've had clients which range from university research labs, not unlike this one, to advertising agencies, to hardware companies. And the common thread that sort of ties all those together, because even looking back, it feels pretty disparate. But in thinking about it, I realized that most of these relationships with these partners in these projects start with a conversation that looks something like this. We don't know if this is possible, but here's what we want to do. And so often we're like, oh, that's impossible, that's impossible. This one we can do. I don't think anyone's done that before. And that's where we the way we normally start. And so this is where we feel really comfortable, is working in these new forms, building these new rubrics and languages for how to interact with things. So that brings us to our most popular title. So early in 2016, we launched a game called Hot Dogs, Horseshoes, and Hand Grenades, or H3 VR for short. It's a physics-based sandbox game for the HTC Vive initially, and now a couple other platforms. And we launched it into Steam Early Access, right as a launch title. And it's done really well. And its success, besides being surprising and made some money, which is nice, has also given us this really fascinating view on how that industry works. And that, along with our sort of contracting background, is where the rest of the talk sort of comes from. So as we move forward here, I want to take a look at where the market's at now and how we see that as informing this work for developers in the future. So first, to sort of talk about what the VR market looks like. And the elephant in the room for a lot of developers is the fact that in the VR world, there's a small market share. And why is this, or sorry, small market cap, market size there. Why is this important? Well, video games are complicated and expensive to make, as we'll talk about, as are all sorts of other things that are functionally like video games, just less fun, I guess. And And this is a problem, because even if you sell one copy to everyone, that's still not that many people. So that's why a lot of people are really sort of down on this. They've seen these projections, and it's not, you know, well, we'll look at how that market works here. But before we get to that, I wanted to just sort of get this out of the way. So VR, or AR, MR, XR, whatever your acronym of choice is, isn't just games and movies and entertainment products. And this is something that we've known for a long time. If you look at architecture, if you look at planning, if you look at scientific research, if you look at medicine, you get all these other fields that aren't entertainment, they're all, as we've seen, adopting this technology in a big way. They're using it, they're integrating it, they're building new things, they're making financial investments into this technology. And as a result, anyone who says that VR, AR, MR, XR, et cetera, are dead are just clearly don't know how much money the architecture industry alone is pouring into this. We actually, before H3, we paid our rent for the better part of a year doing nothing but architectural visualization projects. It's a big part of it. That being said, you've had a lot of discussion on that one, so a lot of the rest of the talk is going to be focused on the entertainment sector, because that's where I spend my time. So let's take a step back for a moment and think about what the current state of the overall ecosystem looks like. So first, we've got this weird phenomenon of infinite demand. So games have very quickly crested into this territory that movies are in, that music has been in for a long time, where you've got this fire hose of new content that comes out on a regular basis. You know, the example I like to give is if you look at Steam, and it's a fun thing to actually try and find the worst possible game. Like some stuff's good, but like the poorest reviewed, however you find it, and you look for the worst possible game, and you'll find some really, really poor titles. And you're like, who would possibly buy one of these? These look terrible. Or it looks not fun to me, at least, in some of those cases. And then if you look at what the sales numbers are, it's hundreds, maybe thousands of people have bought that game. Now, there's a lot of reasons for that, but it shows that there's this huge supply, or that anyone will find your particular game appealing in that way. So the flip side of that is that there's also an infinite supply. So why are all those terrible games on there? Because it's really easy and it's cheap to make these sort of products at the low end. So so who here plays a video game on occasion? A bunch of people. So who here's got some games in a Steam account somewhere? Now keep your hands up if you've played every single one of those games. Okay, there's one or two. It's good. That there's just so much coming out. Now that they've streamlined these publishing processes, that you've got hundreds to thousands of games coming out every month. And that's just on one platform. You've also got other PC distribution platforms. You've got video game consoles. The mobile front, it's hundreds of games per day that come out there. So what does this mean? What does it mean when you've got infinite supply meeting infinite demand in that case? Well, the gotcha here is that it changes how this industry needs to work. That instead of finding the right product and finding the right market, it's all about how you connect supply to demand there. So one of the cases here is how, like, the advertising industry. So this is how AAA video games solve this problem. You take your production budget, and you take that much money, $50 million, whatever it was, and you just take that much more money, and you buy every billboard in Los Angeles, and you sell enough copies to make up the difference. If you look at Google and Facebook, for instance, they're both advertising companies. You know, they offer different products and stuff, but they're both advertising companies because it's about connecting the supply and the demand are the biggest parts of that. So that's all pretty depressing in a lot of ways there. But importantly, the VR games market and the VR entertainment market generally is not the flat games market. It isn't at that, and we're going to talk for a couple reasons, a couple ways in which it's different. But this is actually really good news for all of us doing this sort of work. So the first point is we haven't hit any saturation point yet. So on the hardware front, there's millions and millions of users that haven't bought in yet. These are users that are interested, that will eventually invest in some hardware or invest in access to hardware. And so as new hardware improves, as costs get better, you've got a giant market, and that's going to continue to grow, which is good news for everyone. On the software side, there just isn't enough content at all. The people who are already buying this content want to buy more. If they bought every game on Steam, they're going to buy every game on, available for a while. So that's some good news there. Cost is still a huge factor, and this is sort of why we've hit that. That on the consumer side, the cost of the hardware, the cost of what it takes to develop and to move a new product to market. We've seen a couple of hardware companies here today, and well, why don't they just sell to everyone right away? Because cost is a huge problem. And on the consumer side, or on the developer side, you've got what it costs to develop software too. Like these are really complicated pieces of software that you need to build. And so there's this chicken and egg scenario, and we've all heard about like when will the big AAA game developers start investing in this kind of content? Well, when there's a big enough market. When will there be a big enough market? When there's content to lure people onto this market there. So it's an awkward scenario, but it will only get better. On the development front, performance is a headache. It's not just sometimes it's a literal headache too, that you're going from we hit 30 frames per second and you're doing good to you need to reliably hit 75, 90, sometimes 120 frames per second at much, bigger than 4K resolutions. And if you drop those frames, your users don't just have a bad time, they get sick, or they get a headache, or they trip and fall. Like the stakes have never been higher performance-wise, and that's just a really hard thing to do. That's not going away. Like resolutions are getting bigger. This arms race is going to be a real pain for a while. But in the end, I think Moore's law will sort of catch up, and it'll get better. Community is super important, and this, as we're talking about this market as it develops, this is one of the places where you can still get organic community growth. H3 is a niche game. It's a gun simulator. We've got 3,000 die-hard fans on our subreddit that post regularly. We've built communities on YouTube, and we've built communities elsewhere. And while we've done an okay job, we're hardly experts in that field. That this is one area where you can still have that kind of organic growth, and that's enough to buoy a company. If you want to build a mobile game, you need to be spending as much as you're spending on your salaries on advertisement to keep your user community up. And the minute you stop spending on that, they move and go somewhere else. Because of where this market's at, because we haven't hit the saturation point, the VR market is way more forgiving along those lines. If only it was cheaper to make games, it'd be great. So then to shift a little bit into that's all really good, and I think that the takeaway here is we need to focus on building these communities and having centers and groups of people that are doing this kind of work and building those communities is super important. So one thing we've seen, and this is as a designer, at heart I spend my time designing stuff, we're seeing this interesting crossover, and this is across both the professional and industry spaces as well as the entertainment space. But using solutions that exist from other fields is going to be increasingly important as we move forward here. We've got these environments that we're in are increasingly realistic in ways that we never thought about before. It's not just how it looks or how it sounds, but now how it feels, how you move through it. And while that takes a lot of rules and throws them out the window, we've got solutions in place that we can pull from other industries. So in terms of the design language, if we think about Quake, So you played Quake with the WASD keys and your mouse. So that gave you 2 axes on your left hand and 2 axes of control on your right hand. And you had to control an entire human avatar with 4 axes of control. Now, fast forward to say that the DK1 era hardware. And suddenly, you've got a couple of axes of control on your neck. So instead of controlling where you look with your hands, you control with your neck. As we move forward into the DK2 and CV1, suddenly you're getting more nuanced control. So suddenly you're able to move your whole body around. And that's, flight sims got awesome all of a sudden. You don't need to worry about, oh, what's the button to look behind me to see if I'm getting shot at? You just look behind you and see if you're getting shot at. As we move all the way into, say, the Vive and the Oculus Touch, suddenly you've got, there's no way to get this movement with a mouse and keyboard. Like you can't get your hand to do that, and it's trivially easy all of a sudden. So what does that mean? Well, one, with every one of those changes, we need to sort of throw out the book and write a new one usually. But this also means that we can move closer and closer to these design areas that we already know. Ergonomics, human factors, basic UI, UX sort of things. Stuff from those fields are going to become increasingly relevant. Well, where should we put these things? Make it a lever that you can move physically. Like how do we make our train simulator awesome? Build it like a train. Somebody already designed that. So I think that that's one of the exciting parts of this design space, is being able to pull in more of these fields. Which sort of brings to the final point here about accessibility and audience. If we think about, for a moment, what made sort of cell phones so compelling. Now there's cost and there's price, and there's lots of factors there, but one of the things from a design standpoint that I thought was really compelling was, when you want to do something, how do you interact with it? You don't move some other object somewhere else and have something translate. You just touch it. And that seems dumb. You're like, of course you just touch it. That's what you... But that kind of one-to-one direct interaction made that so accessible. That's why you've got the, oh, suddenly grandma can use this. Suddenly my 2-year-old can use this computer. And as we've heard other speakers talk about, that accessibility is crucial. We're in for an even bigger change with this new hardware. If you know how to use a flashlight, you know how to use a flashlight in-game. You hold the thing and you point it at what you want to point at and interact with. Suddenly the barrier to entry is so low. You don't need to know what buttons are which. You don't need to know which joystick does what. If you can walk through the door, you know how to use the Omnideck. If you can look at the clouds, you know how to look at stuff in these virtual spaces. There's a whole host of people that have been excluded from these virtual spaces for the difficulties in these areas. And those are people that are ready and waiting to go. Those are new markets, and that's where things are going to truly explode here. That we're going to get not just better and better versions of the content that we've already got, and we will get that, but we're also going to get whole new genres that none of us have thought of before, because suddenly people who couldn't deal with this are going to have access to these virtual spaces. Thanks. I will be around if you want to catch me afterwards, too.
All right, now we are supposing to have this short panel. It seems that Urho and Varjo are still setting up their demo. So I simply suggest that we skip the panel, and all speakers will be around in the CIVIT premises. Coffee will be also served. So we simply proceed to the demo session, and whoever wants to discuss with some of us, you are very much welcome to do it together with a cup of strong coffee. Thank you once again for visiting the presentations, and see you in the CIVIT premises nearby. Thank you.